We have to find the absolute maximas and minimas of the function fx as x plus 2 cos x in the interval of negative pi to pi. So definitely for maxima and minima, we find f prime x and hence the critical point. Differentiation of x is 1. Differentiation of cos is minus sine, so that's 1 minus 2 sine x. And to find the maxima or minima, we equate the we equate the derivative to 0 to find the critical point. So that is 1 minus 2 sine x should be 0. This means that 1 should be equal to 2 sine x. Dividing both sides by 2, we mean that 1 over 2 is equal to sine x. This means that sine x should be equal to 1 over 2. Now remember that x is in between negative pi to pi. And if we draw the curve of sine x between negative pi to pi is like this. Since sin x is only 1 over 2, so it cannot be in this region because it's completely negative in this region. So it's 1 over 2 will be in this particular region, and that too in quadrant 1 and quadrant 2, because in both the quadrants sine is positive. This would mean that the one of the value in quadrant 1 is going to be sine inverse 1 over 2, which is pi over 6. And in quadrant 2, it is pi minus pi over 6. So that's going to be 5 pi over 6. That is one of the value. And another value is pi over 6. These are the two values. Okay, now we are interested in finding whether it has a maxima or minima. So that's where we are interested in knowing the sign change about of f prime x about these points. So this is pi over x, this is 5 pi over x. Any number which is more than 5 pi over 6, if we put, let's say we put pi, sine pi is 0, so 1 minus 0 is 1, so we have a positive number over here. Any number between pi over 6 to 5 pi over 6 can be pi over 2. So sine pi over 2 is 1, and 1 minus 2 is minus 1, so that's negative. And any number less than pi over 6 is and let's say 0, so sine 0 is 0, and 1 minus 0 is 1, which is positive. So this is also positive over here. So since this is how the curve is changing, this would mean that this point will have a local maxima and this point will have a local minima, because the derivative is changing the sign from positive to negative and here negative to positive. So here we have a maxima and here we have a minima. This we are talking about the local maxima and minima, but they are interested in absolute maxima and minima. So not only we need to find the values at this point, but at the terminal points as well. So that is x plus 2 cos x. If I've written this correctly, x plus 2 cos x, yes. So first I need to find the value at the critical point. So f of pi over 6, that will be pi over 6 plus cos of pi over 6 is root 3 over 2. So that's 2 times root 3 over 2, which is pi over 6 plus root 3. F of 5 pi over 6 will be 5 pi over 6 plus 2 times 5 pi over 6 means quadrant 2, and in quadrant 2 cos is negative. And we already have the reference value over here, which is root 3 over 2. So that's going to be negative root 3 over 2. So that will be 5 pi over 6 minus root 3. Okay. And then we find at the terminal point, that is it is between negative pi to pi, so we find at negative pi. So that's going to be negative pi plus, and cos of negative pi is same as cos pi, so that's negative pi plus 2 cos pi, and cos pi is minus 1, so that's minus pi minus 2. And then we have f of pi, which will be pi plus same as 2 cos pi, and cos pi is minus 1, so that's going to be minus 2 over here. So now we have to find this approximate value of all these four numbers to find the absolute maxima and absolute minimum. So let me just do that. The first one has an approximate value of 2.26. The second one, 5 pi over 6 minus root 3, is an approximate value of 0.89. Then we have minus pi minus 2 is close to negative 5.14. And finally, we have pi minus 2, which is close to 1.41. So we can very evidently see that the maxima is this number. So I'm going to highlight this. This is the maxima, and minima is this particular number. So I'm going to write over here that this is the maxima, absolute maxima, and this is the minima. Thank you.